Good evening, everybody. So today I'm talking about microservices, and this is me learning English. My teacher, Richard Espinal, asked me to give a talk like this every week, and I accepted the challenge. So this is me reserving my rights to make mistakes during the presentation. So microservices. Say microservices one more time. So I find this image very interesting because some people can't stand anymore hearing about people talking about microservices. It's a hype. It's a very new concept, and everybody is interested about that, about learning more about this new kind of architecture. Let's see how it works and why it's important. So this is the way we usually build applications. We have here a back-end and front-end service and a database. Just one for a application, and this could be fine if you have a small application, but as your application keep growing and growing and you're getting more users, this could become a big mess. So Netflix, for example, they started in 2008. They have just one web app, a Java WAR file. For those not familiar with Java, this is a package, a kind of a zip file with all the files of your application. So in 2010, they had already more than 100 fine-grained services, microservices. But what's the matter? Why they needed to do this change, and why microservices are so important? When we have a monolith like this, a big application, we're gonna have some problems. For example, developers are afraid of changing the code. So we have so much code and everything is so coupled that we can change something here and break something there. So they are afraid to change the code and break something else. It's hard to understand what's happening with too much classes and concepts and code in the same application. You need to deploy the whole thing to change a simple component. So you need to change a small piece of your app, but you need to deploy everything. And if something goes wrong in one component, you can break the entire application. So it increases the risk of failure in your app. Also, testing can become very slow. Before deploying, you need to test your whole application. So if you have, for example, unit tests or acceptance tests, you're gonna need to wait all the tests to run before deploying. So this could be a big problem too. Your IDEs and web services will be overloaded because your application is so huge, and it's going to be really hard to scale development because you're going to need a very big team to keep your big application. Also, it's going to require long-term compromises with technologies chosen. Say, for example, you have written your app in Java, and now you need to change to Rails, to Ruby on Rails. So it's going to be really hard to rewrite everything. If you have microservices, you can just rewrite a small component. It's going to be really fast, really easy for you. So this is the difference between the two models. We have here, instead of just one back-end and front-end service, we have a front-end here. That could be also separated, but let's say that it's just one front-end. But in the back-end, we have multiple databases that can or cannot be shared by the same services. And you have multiple services to do the same job that you were doing before here in just one. But what's the game? First, development is much simpler. So you have less risk, you have just a few classes, just a few components. Everything is fast, everything is easy to understand. You don't have the old class path hell. For those familiar with Java, this is a big problem. When you have a big application, you need to keep finding dependencies in order to do what your application needs to do. And when you have a lot of dependencies, this could be a big problem to manage. Your build and deploy are going to be much faster. It's more scalable, as you can break your big team in many small teams, and each small team could be responsible for each of your microservices. You have more freedom to try and choose different technologies. It's easier to change the technology of a small component than a large component. And you have more isolation and reduced risk of failure. But what are the challenges? What are the problems that you could face when you were moving from a monolithic application to a microservices application? First, it's very complex to operate and distribute this application. For example, you need to monitor your applications to see if the machines that they are running are okay, if the CPU is okay, if the machines have enough memory. If something goes wrong with a machine, you need to know it before your customers start to complain about your service. So when you have multiple microservices, you need to monitor more machines and more services, and this is more complicated. Also, you're going to need to manage more databases and transactions. And if you need a single transaction to go through more than one microservices, this is going to be really hard, because if something goes okay here but then goes wrong in the second microservice, you need to roll back what you did in the first one. So this is not easy. It's much easier to manage transactions in a single application, as you have frameworks that do the job for you. If you need to test just a single microservice, this is really easy. But if you need to test the integration between 2, between 3 or 4 different microservices, this is going to be hard too. So testing distributed systems is hard. Coordination of changes that affect multiple services, like the transactions that I said before, is going to be a problem too. But the good news is that the community is growing really, really fast, and you have new projects and patterns coming every day, and it's going to become easier and easier and easier to face those challenges that I said before. For example, we have Docker. We have a Docker fan here. That makes really easier to deploy microservices in containers. We have Drop Wizard and Spring Boot that makes easier to create small applications in Java. And Netflix, that I started the presentation with, is a pioneer in this kind of architecture, and they have frameworks, open source, that helps you a lot. So for example, you have Hystrix to make these circuit breaker patterns. So for example, if something goes wrong with one microservice, you can redirect all your traffic to a fallback microservice that get this traffic for you. You have Eureka as a service registry. So you can, for example, registry all your microservices in Eureka, and whenever you need a microservice, your application needs some specific service, you can ask Eureka where this service is running, if it's running okay, and you can load balance in client side with Ribbon, and use carry on to make it easier for you to communicate with other services. So Netflix now has more than 50 services available, more than 50 projects available, all open source. So it helps a lot to start. And the community is growing a lot, so I think from now on everything's gonna be easier and easier and easier. So I hope I could help you guys to understand better how these concepts of microservices work. Thank you very much for your attention. If you need to